our paper is about regional convergence between Russian regions, and we make basically our paper is empirical, but we form and estimate a theoretical model for this convergence. Well, very brief introduction to the topic. The issue of convergence is very interesting and very relevant from many points of view. The general issue is, so can poor or developing countries catch up rich developments? And the economic growth theory, the basic tool to analyze this issue is the classic solo growth model. And generally it predicts that poor countries should grow faster than rich ones. And by the end, they should converge in terms of GDP per capita or in some other measures of economic development to the rich ones. But of course, in the real world, many poor countries do not grow faster than rich ones. And the issue is in these other things which are actually not equal. And many empirical papers, they study the so-called conditional convergence. So they consider countries which are more or less similar in many things, and basic things for this model is savings and population growth rates. And in samples of more homogeneous countries, the basic result, the common result is convergence rate about 2% per year. And we consider larger samples which consist of countries which are more heterogeneous. We should control for many other, so for much more factors different across countries, and we still result, many papers show that convergence rate is about 2% per year. Okay, this was, so the basic model and this basic, the core literature is about convergence between different countries. But of course, there are papers which apply this growth theory and estimate convergence rate to the regional convergence. And this is an important extension, an important variant of convergence analysis. And this regional perspective, so when we consider regions within countries, fulfills better this ceteris paribus condition. So, of course, regions within countries are much more similar than separate countries. Okay, they share common institutions, history, backgrounds, and so on. So, this could be a good application to this growth theory of convergence. And still, at the same time, the issue of convergence of regions within countries is a very policy relevant issue. So it's of great importance to know whether regions converge or not. And there are dozens of empirical papers on regional convergence within countries in the United States, and papers that consider Europe as a whole, as a large region, and consider different European regions, do they converge or not. And one of the recent papers, which is by Giannoli, Laporte, and Schleifer, published in Journal of Economic Growth, they combine these two approaches. They combine national analysis of national convergence, so convergence across countries, with subnational level convergence of regions within countries. Okay, so in our paper we study convergence between Russian regions, and couple of slides about Russian context. Russia is a large and very heterogeneous country. This is just one table to illustrate this point. This table was taken from the recent report by World Bank. For example, we can consider Russian regions, differences between Russian regions comparable to differences existing between separate countries. For example, in terms of GDP per capita, one of the richest Russian regions are comparable to countries like Singapore and United Arab Emirates. For example, Moscow city is comparable to Netherlands, and bottom 5 regions, the poorest Russian regions, are comparable to African countries in terms of GDP. So differences between disparities between Russian regions are comparable to disparities existing between different countries. So the scale, the magnitude of regional disparities in Russia compared with other countries is high. So this also graph taken from the OECD discussion paper shows that Russia here is on the second place. So disparities, regional disparities in Russia are much higher than, for example, disparities between Brazilian provinces, within China, or within many other developed and developing countries. Okay? And at the same time, these disparities were rather stable. So we can trace the dynamics of the coefficient variation, one of the standard measures of variation. And it shows that it has some periods of growth and decline, but still we don't see that these disparities decline in time. So, and what we already know for Russia from the literature. There are, of course, dozens of papers on Russia, and we can distinguish very roughly 3 periods of analysis. 1990s, and in these years, most papers show that it was no convergence, or never unconditional, no conditional convergence. When we consider a longer period, it takes 1990s to 2000s. Most papers show slow conditional convergence around 1% per year. And when we consider more later period from 2000 to 2010, large heterogeneity in results, but most papers show more rapid convergence, which may exceed 10% per year. Of course, these results depend on the methodology, and they are not really comparable between papers. Another fact about Russian convergence is that spatial effects exist. So regions are spatially connected to each other. There are special interdependencies in many characteristics, and they matter for the issue of convergence. At the same time, almost all studies on Russia used ad hoc specifications of growth equations. So their empirical work was not based on theoretical models. And at the same time, the role of different factors like migration, human capital, spatial effects, state policies, etc., has been examined not systematically. So what we do in our paper? We examine convergence between Russian regions. We consider the longest period available, and we base our empirical growth equations, so our regressions are directly derived from the theory, from the Solow model extended with human capital and migration. And we apply the latest methodology and take into account spatial effects. So I will not spend much time on the theoretical model. This is basically the Solow model with some extensions. I will skip this, and I will go to the final equation, theoretical equation, and empirical growth equation, which is reflects our final equation. So equation 9 is our empirical growth equation, which we estimate, and using these estimations, we derive theoretical parameters. We derive convergence rate. We derive physical capital share, human capital share, and we also derive parameter ratio of human capital of immigrants versus natives. So this is key theoretical parameters from the Solow model extended with migration. And you can easily see that our empirical equation, which we estimate, is directly derived from the theoretical model. Okay, and we also take into account spatial effects. We introduce a spatial lag of our dependent variable and estimate the whole model using system GMM estimate. With data always simple. Our main data source is Rosstat regional statistics. All data are available, and these are our main results. So first of all, we estimate a model using pooled data, and the first row shows the coefficient of interest and the coefficient of convergence. So when we estimate our pooled model, we don't receive significant coefficient, and the reason is that this estimate is biased upward, because we don't take into account regional fixed effects. We have omitted variable bias. On the second step, we include fixed effects. So this is the second column. And here we receive very large, in absolute terms, negative coefficient. And it reflects another type of bias, the so-called nickel bias, because our regional fixed effects are correlated with our variable lag dependent variable. So all these methodological things are explained and described in the text. Okay, and finally, the last column, our final estimation, we use system GMM, and we receive that this coefficient is about 0.6, which implies convergence rate about 1.6% per year. We make many robustness checks. One of them, I will not explain all of them. One of them that we assume different rates of technological growth and amortization. In the literature, most papers follow Menke-Römer-Weil classic paper, which assumes that G plus delta is equal to 0.5, but we make alternative estimations for Russia and assume different values for these parameters. Okay. So, and finally, based on our estimations, we may derive theoretical parameters. So our convergence rate is about 1.6% per year. This is higher than in the literature that's found in 1990s, but still lower in the literature which considers the latest period from 2000 to 2010. And this is remarkably close to the 2% rate, so-called iron law of convergence, which was found in many studies across different regions and countries. Our physical capital share is about 0.5, and this is close to some alternative estimates. And finally, the ratio of human capital of immigrants versus natives. This theoretical parameter important for the solo model, which is extended with the migration, shows that migrants on average have high amount of human capital than people who don't move in Russia, and this is in generally true and very close to what we have. And finally, we analyze the role of different factors. We estimate full model and then exclude different factors and analyze what's going on with our key coefficient convergence. And what we receive that special interdependencies, so spatial effects, they contribute to convergence, but this contribution is not very strong. At the same time, migration contributes to divergence in Russian case. And human capital contributes to divergence, so these factors impede the hamper convergence. Okay, so actually you can see our summary and our preliminary conclusions on the slide, and that's all.
Okay, thank you very much for your presentation. We will now have a comment by Robert Steller.
I'm sitting on a place without the mic, so well, thanks for inviting me to discuss this paper, which I liked very much, but I think there's still some scope for development for this paper, and I will link to some of the points I came along when reading the paper. Maybe it's because I didn't understand completely the framework, but this is basically just when reading the paper and I have some. First of all, I was a bit struck by the title, Estimating a Comprehensive Model of the Russian Regional Convergence. My knowledge of the growth literature is, meaning what is a comprehensive model of growth. And it has in the beginning 2000s there have been this discussion on the Bayesian econometrics and model selection things. And there's a paper by Stephen Durlov. I think he surveyed more than hundreds of papers, and basically his conclusion was the 150 growth models with about 250 covariates, which has to be taken into account. And then basically on all these model selection results, it's the legalness, the human capital investment, which are the most robust indicators of convergence in the sense. So that's why this comprehensive is a bit of too much, I think, to be in. So the paper aims to do this by basically accounting for human capital accumulation and migration flows in the soul of growth model, and an additional step which goes beyond the typical soul of model to include spatial effects, because that's for regional dynamics quite important. The claim why they're starting from the soul of model is that they want to avoid ad hoc specifications. And therefore they base it on this neoclassical framework of Solov. But I think there should also then be discussions on the limitations of that, right? Particularly in the regional context, one has to take account for scale and agglomeration effects. There might be resource curves for some regions, there might be specialization effects for some regions, which are even more important than for doing this analysis at the country level. For example, if we would do a similar exercise for the Eastern European countries at the regional level, that's two, basically you find convergence mostly because there's convergence for the capital cities, but there's strong divergence between countries for the regional cities, right? Because the agglomeration effects are quite important, which has to be taken into account, which is not in the Solov model. So there are other endogenous growth theories which add additional effects which might be important in this context. Well, in the presentation, you talked a bit more about conditional convergence, which I didn't find that much in the paper, but I think that's an important point, that some regions are stuck by their conditions which are not easily to overcome. And I think all these points are more important at the regional and short-term level because they estimate a yearly panel rather than a very long time span of panels. On the theoretical framework, well, you start from a standard growth model, Solov model, and include growth of human capital in the growth equations. I worked on the growth theory in literature 15 years ago, but I wondered if you include a second factor of accumulation, you also need a second kind of optimality condition, like in the Solov model, the convergence is to this K-star, which is the optimal level of the capital-labor ratio. And then you would also have something like an optimal convergence to the optimal human capital-labor ratio. This is not in our paper, it's ad hoc human capital dynamics, but I think this would be a nice add-on to the literature, which maybe it's existing already, but this is what I think is important. Then you include the migration part, and you include that by having the growth rate, it's n for the population, and you add the ratio of migrants to the native population L. So M is a kind of ratio, whereas the N is the growth rate, and you add this into one kind of growth equation, which I think is not that consistent, because then it should be the growth rate of the migrants over population rather than the level of it or the ratio of it. An important point, and this might explain some of your results in the end, is that if you have a strong intra-Russian migration, which I'm not sure where it is, but I think it is, then by definition you have some negative M's or some outward migration of some regions, which goes exactly in the other way. And then maybe this explains that some regions are converging, attracting migration, others are diverging because they lose population and so on. I think this needs some more discussion in the paper, if inward Russian migration is, intra-Russian migration is an important topic. Migration has two opposing effects. Well, the one is because you have less capital accumulation if you have higher population growth. It's a standard Solow term. Then you have a positive effect because you increase human capital. If this epsilon is larger than 1, then you have a positive effect. On the derivation, well, I come back to this endogeneity of migration later on. On the theoretical framework still, you derive the steady state dynamics, and I thought a bit and it was puzzled a bit, because in your derivation, the growth rate of productivity, G, enters negatively, which is opposing the Solow model, because G is the exogenous growth rate of productivity is the one positive factor driving GDP per capita. I think that the reason is why you get this effect is that you derive your capital and human capital dynamics equation in effective units of labor, so you divide by AL, whereas in the dynamics of income per capita, derived in terms of GDP, you would get a positive effect. So, and you derive it in effective units of labor. The regression you specify in the estimation is in terms of GDP per capita. So it's not the effective capita, but per capita. And this drives some kind of thinking, I think, and this could be easily remedied. It's basically to sort it out. Okay, on the estimation, you opted for a yearly panel, which is okay, but also has its positive and negative, its advantages and disadvantages. You discuss them somehow in the paper. I really think it would be good for the paper to also add some 5-time periods or longer time periods equation to really show that the results also hold over the longer period, because these panel dynamics can be a bit odd. So you include regional fixed effects, which I think is okay. Time fixed effects, one should discuss whether you really think the shocks across the regions are the same, or whether there's an oil price shock affect one Russian region much more than another Russian region, which is not picked up then in a sense. And you include the spatial term, which you include in a contemporaneous way. There are also some literature including it as a leg term, but I think this is just to play around in the specification of robustness checks. Suddenly in the estimating equation, the migration term you treat separately. So in a sense you derive it, it's combined with human capital equation, but then it's estimated separately, and I wondered how this is the case and how this could be derived in more consistent way. But then you estimate GMM and you proxy human capital by R&D, and in the paper so it's not this robustness check using high skill share of labor, but that can be added. So the results in general are in line with the expectations, at least for the science. But in the end, you derive some theoretical parameters, particularly the one on migration. And this is by basically calculating beta 4 divided, I think it's beta, it's not beta 1, but beta. But my concern is that beta 4 is estimated very imprecisely, so it's not significant. And you derive from this parameter 3. Could also be 0 divided by 0.16, 0.016, right? So it's not estimated significantly, and so it's not easy to judge from that any kind of result. One remark: migration is likely to be highly endogenous, so faster growing regions attract migrants. So that might be taken into account in some way or the other. I don't know how, but that is one of my concerns. And finally, on the robustness checks, I'm really concerned about the robustness checks. They're leaving out one variable and just running the regression again. So in the paper you write both migration and human capital appear to be strong factors of divergence, as the exclusion of them from the growth equation leads to both economical and statistically insignificant parameter of the convergence parameter. Well, first of all, it completely is opposed to the other results in the normal growth regression table. Second, you might have an omitted variable bias by this kind of robustness check. So for migration, I would understand, because, well, we have this positive and negative effects depending on whether you have net immigration or net outward migration. And anyway, that's why a reason why it might be insignificant in the other growth specifications. Okay, so this way.
Good. Thank you very much for your comments. We have a couple of minutes left for questions and comments.
Yeah, I can say something. So maybe you can send us a slide.
Yes, please, sure, welcome.
I don't think, if I'm not mistaken, we do not only look at annual data, but we don't have this 3 years.
No, the average over 3 years.
Average over 3, okay, so my
Annual data.
Yeah. But I mean, in a panel specification, which, because well, there's a lot of literature in that you have the long-term convergence is different from the short-term adjustments and so on. So it's just another robustness check to
different average.
To on 5 years terms or 10 years or from crisis from peak to peak and so on. So
just like clarification, how did you measure output levels? Did you compare regions by output levels? As far as I understand, in convergency, which is very strange to that.
Output levels.
Levels, yes. Levels of activity somewhere, some level comparisons.
We just use GDP and publish GRP, cross-regional product.
In terms of price levels.
We use in real terms. We deploy using
This is about comparison.
volume is
time.
this, in time.
And that's true, but my question is about comparisons across the regions in 1 year, for example.
No, we don't do any adjustment across regions.
so the question is whether the PPP
Yes,
adjustment.
exactly.
For price levels, I mean.
Price levels, they
We don't do. Well, I know papers that try to do this and receive similar results. We can try this, but for now we decided not to do this because one of the points that we don't have really good, not price measures, good measures for this adjustment. We have only fixed for price for goods and services, but don't have prices for all components of GDP.
But for the growth regressions, it wouldn't matter if these price differences across regions change quickly over time. Also, right? If these price differences across regions are more or less stable, it doesn't matter for the growth rates.
They are stable.
If they're stable, right? Exactly.
In principle, there is some data on differences in prices across Russian cities. It's not about regions, but cities.
But I mean, the point is that we only have to rely on the data to do across regions.
That's right.
That's all I can say.
Probably some sense.
So by introducing more, but introducing noise is also